Welcome to A Fresh Face in Hell. I'm your host, Jonathan Evison. Every week we talk to someone new and interesting, somebody intellectually curious, somebody who will hopefully renew our faith in this cold, cruel world we live in. A Fresh Face in Hell. Today our guest on A Fresh Face in Hell is Carl Zimmer from the New York Times. He's generally considered one of the preeminent science journalists out there. He's written 15 books on various subjects, but it's his most recent book, Borne, The Hidden History of the Life We Breathe, which is going to figure prominently in our conversation today. We're going to talk about the air we breathe, specifically about the germs and viruses that populate that air. How they propagate, how they function, what threat do they pose to us? Are we on are we on the verge of another global pandemic? Is there anything we can do to prevent? What is the scientific community learning about germs and viruses and their propagation? We're also going to talk about the history of germ and virus research, which stretches back over 1,000 years and is pretty fascinating stuff. So, Carl Zimmer, welcome to A Fresh Face in Hell.
Thanks for having me.
First of all, I gotta say this book kind of scared the hell out of me. I wanted to take a shower, but then I was afraid of the water, and then I was afraid of the towel, and then I was afraid of sitting down in my chair, and then I was afraid to pet my dog, and now I'm afraid to go to the beach. And now when I look up at the sky, I have different thoughts than I previously had. So I'm hoping at some point during this conversation, you can talk me off this ledge.
Sure thing.
But knowing everything you know about the aerobiome, about the let's call it the exponential propagation of germs, literally everywhere around us, how do you cope, man?
Yeah, it is I have to say that I have a fondness for freaking out my readers. I mean, about 20 years ago, I wrote a book called Parasite Rex, where I wrote about how parasites are the most successful life forms on Earth, and a lot of people were very disturbed to discover that there are millions of parasites all around them. So this is a different take on that, in the sense of, like, they're not just around us, but they're floating around us, and we're breathing them, and not just parasites, but all sorts of different organisms. And I guess just one thing to think about is, like, well, I mean, ever since our ancestors crawled out of the ocean some 400 million years ago and started breathing in air, we have been part of this aerobiome. I mean, there's been life in the air for billions of years, and we have become a part of the air because we take thousands of breaths a day, and we're constantly breathing in and out life. And sometimes it makes us sick, or really sick, but a lot of times it doesn't. And in fact, sometimes it might even be good for us.
I think, I mean, we're kind of parasites and germs on this earth, really. I think we have a way of human beings as framing things as, like we frame plants we don't like as weeds or invasive species, and that helps. Thanks. Today's, this is going to be like a therapy session because I do not want to become a germaphobe. I've been around germaphobes and they're just really weird, and I don't want to become one. Um, Let me ask you, what did we learn from COVID?
You know, we learned a lot of things from COVID, but I think what I really wanted to explore deeply in my book was recognizing that COVID is airborne. And this is a simple fact. It's doesn't You don't need to know quantum physics to know that COVID is airborne. But it took a remarkably long time for the scientific community to sort of settle down and generally agree, like, yeah, this is how COVID spreads. And once that happened, I think that a lot of people, including scientists who you think would have already known about this stuff, really started to think seriously about how diseases spread through the air and how do other things spread through the air. Like, the air, in a way, has been incredibly invisible to us. Not just that it's a transparent gas, but we've ignored the life that's in it. And I think the COVID pandemic really kind of shook people, because they realized, oh no, there's stuff floating around us, and sometimes it can kill us.
I'm still sort of traumatized by the my remembrance of standing outside in the cold 10 feet apart from my friend with a mask on, having these conversations because we were so desperate for some, interpersonal communication. Uh,
Now,
did
I would just point out, just to help you with, we don't want you to become a germaphobe. We need to, we are a social species. We need to be with other people, and that's one of the really frustrating things about COVID. It was it would really prevent these kinds of communion. Singing, for example, became very dangerous. But remember, the real threat was breathing in air that was unventilated indoors, poorly ventilated, because then that's a great opportunity for the air that I exhale to be floating around and for you to inhale it directly. But if you're outside, honestly, like if you're outside 10 feet away, you do not need masks to be safe from what someone else is breathing out. You just don't. But we didn't, it was hard to know that during the pandemic. It was a very stressful, confusing time. But we've learned things and things have become more widely known. So think about that. Just the outdoors is a pretty good place to be.
so was I wasting my time lysoling my groceries that the guy was leaving like a half acre down the driveway? Like, I mean, did we say what it was still contractable via touch too? Or was it just
No, not
exclusively airborne?
in hindsight, it looks like surfaces just do not spread COVID very much. Now, there are other things that surfaces are, you definitely want to be careful about them. None of this is to say that you shouldn't wash your hands because there are lots of other things that you can pick up and get sick from, you know. Um, I don't want to get norovirus, for example. None of us want to get norovirus. Norovirus, you're not going to worry about people breathing it in. It takes a different route, and you want to be careful to wash your hands so that you don't give yourself norovirus from surfaces. But for COVID, in hindsight, yeah, turns out that wasn't a really effective thing to do. Um, and it would have been great if we have been able to come to that realization a lot faster. But when you're in the middle of a pandemic of an entirely new disease, it's kind of hard to know everything all at once.
Yeah, I still don't know definitively whether or not masks work, or do they
Masks
work on
work.
everything? They
Mask
do. Even
mask
so, because
masks
I'd heard droplets were too small to get through the fabric, or are different germs different sizes in that respect? I'm gonna ask you some dumb questions. It's kinda
oh,
what I
no.
do.
D
But I mean, are
those are
different
those are
germs
the best questions. No, honestly, basic.
different size germs
Yeah.
that could get through masks that whereas others can't, or
So so here's the thing with masks. First of all, they are not a perfect panacea. In other words, if you are wearing a mask, you might still get COVID or some other airborne disease. It's not going to be 100% effective. When public health experts are talking about how masks are effective, they're saying it looks like they were effective at reducing the overall transmission of a disease. So, from a public health perspective, if you can cut it down by 10%, 20%, 30%, that's a lot fewer people getting sick and a lot fewer people dying. And so in that respect, you know, uh, masks do work. So, the Royal Society, for example, in England did a huge survey they published last year, and they said that, the weight of the evidence showed that masks, particularly good masks like N95s, generally reduce transmission of SARS-CoV-2 infection. Um, but there are different kinds of masks, you remember like when the Surgeon General was telling us to use cloth masks to kind of make them ourselves. Cloth masks, they might help, but they're not great. Surgical masks are better, probably, but better than that, just from a basic physics point of view, are N95 masks, because they
and you can
can't.
feel it on your face. You can just feel the air tightness and
Yeah,
like the ones they hand
yeah,
out at the hospital, like you get little bacon strips and little wrinkles in them, and you can stick your
sure.
fingers in them.
Yep,
But
they
I
can.
guess, I mean, anything's gonna help a little bit. Now, when you mentioned the norovirus, we're talking about the bird flu here?
Oh, no.
Or is that no, 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 that's
Norovi
the
there's so many viruses. I don't mean to freak you out, but yeah, the norovirus is, and I apologize to your listeners in advance, but norovirus is the one that gives you just horrible, horrible diarrhea. It's the bane of cruise ships where you have these incredible outbreaks where everyone is just totally just racked with this, gut bug, and it spreads, the term for it is, the oral fecal route. In other words, like, people will have the virus on their hands, touch surfaces, other people touch those surfaces. It might be a little bit airborne, but really, like, it's the surfaces that apparently are the problem. You're not gonna cough it out because it's in your intestines, you know? It's not a respiratory disease, it's an intestinal disease. It's generally not fatal, but I've never had it, thank goodness, but from my people I know have had it, it's terrible.
Yeah, we bring our kids to Legoland for every kid's 7th birthday, and I just didn't eat at the buffet this time. I just couldn't do it. I've been on cruise ships, and the first thing you notice, they don't tell you about this in the literature, you know what I mean? Is that there is, like, Purell every 20 feet. Like, they don't, when you see the pictures of the boat, I don't know if they Photoshop that stuff out, but, like, you can't walk 20 feet without a so tell me about there is an avian flu scare
Yes.
happening, like, at present, and, I
Mhm.
mean, can you kinda bring us up to speed on that? I mean, could we be looking at another pandemic?
Well, we know that, influenza pandemics happen. They've happened a number of times in recorded history. The biggest one was in 1918 when 50 or 100 million people died, and you consider that the population of the planet was much smaller. I mean, that could
And that was the flu epidemic.
that right, and then so that was a kind of flu, called H1N1. And so what happens when you have a new flu pandemic is, basically you start with a bird flu. You start with an influenza virus that goes among birds, and again, there it's usually living in their intestinal tract. It's kinda like norovirus, but for birds. Then there can be the opportunity for if the virus is getting into people or into other mammals, it can mutate and then start to adapt to living in our airway. And so part of that transition, scientists suspect, is becoming airborne, so that when you get the flu, you exhale it into the air. And maybe we know that influenza is in the tiny droplets that we exhale just when we're talking or breathing. We just let it out. It also probably comes out when we're coughing and sneezing. And then other people inhale it, and then the virus attaches to the cells in our airway, and then those people get sick too. So now we're really concerned right now about a particular H5N1 strain that it's been going around in birds since 1996, but last year it really started to become even more concerning because it started exploding in cows. And then it turned out, oh, it's actually killing a lot of cats. And this is happening in the United States right now. So we are, really kind of getting kind of into a pretty serious, concerning situation as this virus gets more and more opportunity to adapt to being an airborne mammal virus. And if that happens, we are gonna have another pandemic.
Well, it's scary because I mean, so many I mean, at least according to our recent understanding, so many ailments were not zoomorphic, I think the name is, like, they didn't cross species, like, I'm not gonna give my dog a common cold, right?
You actually, I think we underestimated that. We gave COVID to a lot of animals, a lot of cats, a lot of dogs, a lot of deer, a lot of raccoons. They got COVID from us. And actually, like, and there are some endangered species like chimpanzees and gorillas that are being threatened a lot, not just by poaching or cutting down their forests, but by the diseases that we are passing along to them. So actually, yeah, it's kind of a two-way street.
So, in other words, I mean, everything we kinda thought we knew about some of these germs was wrong. Like,
We're
that
learning.
things couldn't yeah.
We're learning. I mean, with just this is a big world that's full of a huge diversity of life, and a lot of it's floating in the air. And especially when you're talking about uh, invisible life. I'm talking about fungi and bacteria and protozoans and viruses and so on. Um, it turns out their diversity just is completely beyond our imaginings. There might be a trillion species of viruses alone on Earth. So there, we just have. It's humbling how much we have left to learn. So the fact that we know more now than 10 years ago should come as zero surprise.
What's sort of unnerving about this learning process is that we are creating, right? I mean, should we be creating viruses in a lab environment to learn from them? I mean, is this wise? I mean, what could go wrong?
Well, that is actually a debate that's been going on for quite a long time now, because there have you know we we've been gaining more and more sophistication in how we can study viruses and how we can study their genes and so on. And so it is in theory possible to assemble a virus uh, from scratch, even a virus that is no longer present in the natural world. So it could be done in theory for smallpox, for example. Um, so some people have said like, hey, well, we need to understand just as a biosecurity issue, like how could people do that? And they argue, well, we have to understand how that happens. But again, that's a very tricky thing because you're saying like, oh, we need to get better at making these deadly viruses. That doesn't sound smart. And we shouldn't make these things that might escape. Now, and a related debate is about taking an existing virus and tinkering with it to try to understand what kind of a threat it might pose. So say you have a virus that infects an animal like a bird, and you say, what kind of mutations does it need to make the jump to humans? And so back in 2012, actually, some scientists were studying H5N1, and they said, we're going to fiddle with this bird flu virus to see if we can get it to infect ferrets. And we're going to see what mutations matter. And it was hugely controversial. And this became what is set off what's, the gain of function debates. And we're still having those debates now. Um, and, you know, on the one hand, it is certainly true that sometimes there are lab accidents, and so if you are creating things that have a potential to start a pandemic, one slip up could be catastrophic. On the other hand, you know, w we don't know very much about these basic questions about, how does influenza go airborne? And actually, those 2012 experiments, they actually did give us, what experts say are some of our most useful clues about what it takes. So, it's not a debate with an easy answer, I would say. And some people be like, "Oh, that's crazy. Why would you ever do that?" Well, there are reasons that experts have put forward about why they want to do it, but then the question becomes, do the potential benefits outweigh the potential risks?
In airborne, studying germs and viruses, this is not a new discipline. I mean, your book provides a thorough history of man's race against germs. The subject, we've been studying and researching this, I believe you said since the 10th century. Kind of briefly, can you take us through that timeline and highlight some of the specific breakthroughs throughout the centuries that have brought us to this moment? Like some sort of
Sure.
like, watershed moments in studying germs?
Sure, sure. Yeah. So, um, I would say that, there were people people would sometimes suggest that um, that diseases could be contagious, and some people, even in the Renaissance, would talk about there might be seeds of contagion that could spread from one person to another. They didn't have germs in their mind because they couldn't really conceive of that. But it was actually not long after people started talking about seeds of contagion, about 100 years, that people invented microscopes. They looked through them. They said, "Whoa, wait a minute! There are all these microscopic organisms that surround us." And so by the 1700s, you actually had people arguing, hey, these diseases like the plague, they are caused by these what we would call microbes. They are the cause. They are making people sick. They're growing in people and then they're spreading to other people. And many of them thought this must be happening through the air. And other people said, "No, that's crazy. There's no way. You're just fantasizing about these invisible germs." So by the 1800s, really the dominant idea about how a disease like the plague or cholera or typhoid, how it spread was by what they called miasmas. In other words, the air itself would become corrupted.
I
Pest.
almost used the word miasma like 2 minutes ago when I was thinking about my cruise where there was a little GI breakdown. There was sort of a miasma down the hallway as you
Yeah, it's a very potent, very powerful idea, and, when you read Hippocrates really kinda lays it out way back when, in ancient Greece, uh, and you can see that it seems to work, like, why is it that a whole bunch of people, young and old, all in one place start getting sick with the same disease? Oh, it must be that, some bad air just sort of wafted in, and maybe it became from, some marsh somewhere, some rotting material or something. And so
Yeah, that's interesting. That's a logical conclusion, actually. I'm thinking like, yeah, but
yeah, I
they're
mean,
assuming it's coming from some outside force.
sure,
But
sure, and I mean, it's very easy for us today in 2025 to look back and be like, "Oh, those people were stupid. Ha, ha, ha." Ideas last for a reason, they are durable, and it can be hard. It was not easy for the people championing the germ theory to win out. I mean, this took decades, and it took just experiment after experiment after experiment in the 1800s before, people would recognize like, "Oh, like, actually, cholera doesn't really seem to have anything to do with the air per se. But look, here are some bacteria that we always find from people who have cholera, and it's getting into the water, and then that can lead to infections when people drink contaminated water. So the same thing with tuberculosis and so on, and that all happened in the late 1800s. But unfortunately, in hindsight, everyone said, like, miasmas, air, all obsolete, all ancient superstition. Let's just ignore it all. And so you would actually have public health officials in the early 1900s saying, like, there aren't germs just passing out in people's breath. The air is pretty much harmless. For the most part, they would say you don't need to worry about diseases in the air like smoke or miasmas. If someone coughs on you and hits you in the face, okay, that's not good. But you just need to stand back. So, those are 3 foot, 6 foot social distancing rules. They're over 100 years old, and they came out of this view of things, which turns out to be really not right in the sense that, yeah, that could protect you from some things, but you're still breathing in the air, and that air may still have viruses and other pathogens in it.
so I'm a spitter, and it's well known amongst my friends who don't like to stand too close to me. And as somebody who's done hundreds and hundreds of public speaking engagements, I've always noticed that, I don't know, it's just me, but like the front row is always empty. Like nobody, I don't know if I think it's because the word is out that I'm a spitter. I'm gonna come at you with a really dumb question, perhaps here, which is that, are there good germs? I mean, there's good bacteria, right? We know that we need bacteria to digest and things of that nature. But when we talk about germs, is the label germ just mean it's just all germs are bad, all viruses are bad, or is there helpful germs and viruses that help us, like, physiologically?
Well, you mentioned bacteria, and there certainly are some bacteria that you wanna steer clear of. So, Mycobacterium, tuberculosis, like, that's what gives you tuberculosis. There's no good tuberculosis. With viruses, smallpox is not good. There's no good version of smallpox. But That being said, there are actually lots of bacteria and viruses that can enter our bodies and either have not make us sick at all or actually benefit us. And that's so they're both bacteria and viruses that that actually are good for us in various ways. We viruses in particular. I think people sometimes don't realize like we are home to so many viruses, probably tens of trillions of viruses, and they're in thousands or tens of thousands or maybe millions of species. A lot of them are actually infecting the bacteria in our bodies, and that's actually creates a kind of stable ecosystem for us of these bacteria that then can actually keep us healthy by keeping out pathogens. Um, and then even there are lots of viruses that infect our own cells and don't make us sick, which is strange. And no one really knows why this is, but some of them do seem to actually protect us. Some of them seem to cooperate with our immune system. If they're in a cell that might be becoming cancerous, they'll kind of set the alarm for immune cells to come over and kill that cell. Part of our cancer protection is made possible by the viruses that we harbor in our skin, and in other places in our body.
This is why I ask dumb questions. I get a smart answer.
They're
Thank you.
they're
I
great
know
questions.
I have a much better understanding now. I kind of suspected intuitively that there had to be, that because we're talking about a whole biosystem, that there had to be other uses besides just getting us sick. They had to help us immunize ourselves in some way. But the germs are everywhere, Carl. I mean,
I know it.
they're in the ocean, they're in the sea foam, they're in the clouds. Talk to me about how this particular moisture cycle functions. I mean, I have a basic understanding of evaporation, but I mean, where do the germs and viruses figure into this? Because this
Well,
was kind of an eye opener in Airborne.
yeah, so if you go down to the beach and you look out, you may not realize it, but the ocean is just packed with life, especially bacteria, viruses, and algae, other microscopic forms of life, and they're really packed in near the surface of the water, partly because that's where oxygen gets in, and also because some sunlight is able to get in. So you have a whole gigantic ecosystem that just covers the whole ocean. Um, and so then the waves come along and then they crash. And maybe you're seeing them crash on the beach, and you might see some of that spray coming off the top. Well, what's happening with each wave is that some of these organisms are getting trapped in little air bubbles that form during as the waves forms. They pop back up, and um, and then they basically burst, and now you have little tiny little droplets, some of which have viruses or bacteria or algae or other things, and then they take off. And so they're just a staggering number of these organisms are basically taking flight with every breaking wave. Every single breaking wave that you see is launching life into the air. Some of it may fall right back down to the ocean, not far away, but some of it may rise up and catch wind, and the wind might blow it on land. And still, some of it might just keep going up and up and up, actually, until it reaches the clouds.
So it's just evaporates with the germs just go up with it
It's
and
not
evaporate.
evaporation, actually. That's the interesting thing. I mean, evaporation is just where like individual water molecules in a liquid just become vapor. They turn into the gaseous form and they just rise on their own. I'm talking actually about droplets. I'm talking about tiny aerosol droplets that are basically being lofted up by the air. And inside that droplet is a little virus or bacterium or some other thing just floating around inside of it. It's
And it can
circa
make it up thousands and thousands of feet.
miles.
Miles, yeah.
Miles into the sky.
Um,
Yep, and
and
then they can travel for hundreds or thousands of miles before they finally land. They can travel for days before finally landing.
now, The beach used to be a place thanks for this, Carl. The beach used to be a place I would feel very safe, like, if, like, during the pandemic, I would go, I could go take a walk on the beach, all that fresh air blowing, and now it sounds like no better than an alley in Midtown Manhattan. Like, in terms of, like, the number of germs, I think I read somewhere, I think there was a statistic in the book about, like, 6,000 organisms on a single grain of sand or something like that.
That's true. But remember that we are but one species of host. And, if if a marine virus that is adapted for, say, infecting only algae gets inside of our body, it doesn't know what to do. It doesn't have the equipment to infect us. It's dead. It can't make any progress. So, I would not worry about going to the beach and breathing in that ocean air unless, and this is a possibility, which is that if there are sewage systems around which are not working properly and are flooding or they're overloaded and they dump sewage into the ocean. This is a big problem in a number of parts of the world. Then that is going to contain some human pathogens, and they can float around. And people. That's why beaches get closed off for swimming, which is very important because, like, if you accidentally gulp a little bit of seawater and it has cholera in it or pathogenic E. coli or something, you're in trouble. Well, the fact is that those same pathogens can get kicked up into the air in the waves, and scientists have actually been able to capture these sorts of pathogens like on land, blowing in, say, in San Diego when neighboring sewage plants are overloaded. So so I'm not saying that the ocean is free of risks, but we can do something about that. Not just stay off of the beach when there's an overload, but let's deal with our sewage systems. Let's deal with our own pollution, so that we don't endanger ourselves.
And something that's kinda counterintuitive about this as you're talking is that I've always kind of associated, like, sort of stagnant or more placid water as being more dangerous, but now that we're talking about the aerial biome, the more the water's churning up or the more movement in the water, the actual larger danger it poses in terms of, broadcasting these whatever's held in there, right?
Well, there's no question that the ocean waves are generating huge amounts of airborne microbes. There's no question of that. I mean, stagnant water can have its own challenges, like dengue, for example. Dengue is a virus that is really nasty. You don't want to get it. And it's spread by mosquitoes. Those mosquitoes like to lay their larvae in still water. So that can be a stagnant pond, or it can be the water that's pooling up in a, in an old tire in a junkyard somewhere. So, there are a lot of different ways that these things can get us, can there are a lot of different ways that, water can pose a risk, but we understand those risks, and there are things we can do about it. And it's not just the ocean that is the only thing that is supplying the aerobiome. The fact is that, there's probably actually more, viruses, fungi, bacteria, and so on that are going into the air from land than the ocean, even though the ocean is much bigger than the land.
Yeah, now the cloud thing is like, I mean, we just think of clouds as just sort of this pristine gaseous, or at least I did. I would have never even associated, microorganisms, potentially dangerous microorganisms floating around in the clouds. When we're in a commercial airliner, 60% of the recycled air we're breathing comes from outside the plane, right? And then the other 40% comes from the, human petri dishes sitting, squeezed in beside us. So, of all the other reasons I'm not boy, I'm gonna get neurotic here. How do you feel? Let me just ask you this. You wear a mask on the airplane?
I will wear a mask on the airplane, not because I'm worried about the clouds outside, but because I'm worried about the people inside. I'm worried about our little indoor cloud. Um, and I'm particularly concerned when the plane's ventilation systems are not switched on yet. So that is, when you get on the plane, they haven't started to turn on those systems yet. And so people are all crowding in and they're all breathing, and especially when that door closes and you're making your way to takeoff, you're all breathing the same air. So you're all exhaling and then you're inhaling, and it's not that far for a droplet to go to get from somebody who's sick to your nose or mouth. And so, yeah, so I generally will wear a mask then, like, yeah, I'm I will try to wear a mask when when we're up in the air and, the ventilation system is going. But, then for me, I think of it more as kind of a trade-off because, like, I think the risk is lower because there is good ventilation going on at that point. And, like, maybe I want to eat or drink or just talk to someone. And I don't
Well,
know.
you have glasses too. Just even reading, becomes a problem because the glasses fog up and so forth.
Yeah. Yeah.
Now, there are some, one of my favorite parts of this book was that there's some kind of science fiction-y elements here that sort of reminded me about, it sort of reminded me of, Arctic horror stories, like about germs trapped under the ice or whatever. But there's some, there are long dormant germs or viruses that are hiding in plain sight, and one of them is this thing, the valley fever. Tell us about valley fever.
Yeah. Valley fever is a disease that people generally haven't heard of, but I expect they'll be hearing about more in the years to come. The way that valley fever works is that there's a species of fungus that normally just sits in the soil. It's most often like in arid soils, like in the southwestern United States, and uh, if winds come along, they can scour the soil and pick up these spores, and it's particularly easy for them to do so if there's been erosion or construction that's been going on. So, like, human activity can actually make it easier for these spores to kick up and then go in the air.
So, like massive plat developments where they're putting in 4 houses and you've got all these excavators to, I mean, that could potentially, that's as bad as a windstorm.
Well, it just what it does is it kind of loosens up the ground and makes it easier when the winds come. It makes it easier for them to pick up the dust and spores and so on. And once these spores get in the air, they can, like all other airborne life, just go a long, long way. And when they're coming back down, um, people inhale them. Like, it's quite common for people to inhale this fungus. Now, normally, if you have a pretty strong immune system, you will keep it in check or destroy it. But for people who have a weak immune system for various reasons, or maybe they just get a really big dose when they breathe in, it starts to grow, and so you have a fungus, uh, you know, growing and extending its tendrils in your lungs, and then it's these cells are spreading to other parts of your body. Very hard to treat, unfortunately. So it's slowly over the course of years can be lethal, and you know. Valley fever has been, seen a lot in, the people who pick our crops because they're out all day in these farm fields where, they may be not that far from where these winds carrying fungi are traveling. Um, and
And
global
they're tilling the soil and the soil's being turned over constantly, and
Yeah, yeah, but it seems that it's probably more just a question of, like, are you outside and exposed to these winds all day? Uh, and, you're just at greater risk. But we're all gonna be at greater risk in the years to come, scientists project, because of global warming leading to more arid land in the Western United States, a bigger area where the winds are gonna be kicking off, valley fever, and so people across a broader range are gonna be at more risk,
that was
unfortunately.
my next question
Yeah.
was how climate change, affects germs and the travel spread. So it has to do with, a more arid climate.
Yeah, for valley fever in particular, yes. Arid land expands, there's going to be a greater reach for this fungus to get to people. I mean, climate change is going to change the aerobiome in a lot of different ways, but this is one of the most concerning ones.
And you also talk in Airborne about smoke from wildfires and how that can affect both the travel and the spread of germs. How so? And like, what, for instance, could the potential fallout from, say, the Los Angeles fires look like,
Y-
particularly because it's in such a populated area?
Yeah, the uh, when people think about wildfires and the threat that they pose, they rightly are concerned about the particles of smoke that come their way, and inhaling those particles, which are just tiny little bits of charred bark or leaves or what have you. Um, those get into your lungs, and they can cause inflammation. They can cause a lot of problems, and it can potentially lead to problems for your heart, a whole health range of health problems. So it's really important if you're in a place with really bad air quality due to wildfire smoke to have a good respirator, just to protect your own health. And that's just the stuff that's dead. But it turns out just in recent years, scientists have started to appreciate that actually this wildfire smoke is paradoxically full of life. What happens is that when these fires are burning, they're creating these violent updrafts, and they can actually sort of almost lift off, microbes, viruses, bacteria, fungi, and so on from, the leaves of trees, from their bark, from the soil, and those updrafts then kick them up in very quickly high into the atmosphere, and they go up so fast that even though they're in a fire, they're not being torched. They're not being killed. They're still alive. They're still viable as they're floating up there. And so it turns out that wildfires are probably a major, major source of living things in the aerobiome, maybe as much as the oceans. And nobody even realized that wildfires could be so important that way. It's possible that, that may spread diseases like valley fever. That's a possibility, at least in theory, but I haven't seen, like, really good, data connecting that. But, that's the fact that wildfire smoke can be so important for pumping life into the air is really a new realization, so people need to look more closely at it.
The germs are winning, Carl. That much is clear. And now we have all these outside factors, some of which are arguably human created. And I think obviously both of us would agree on that. But so we're going to need to study this faster and faster. And it seems like, humanity is just unable to accrue any sort of scientific knowledge without finding a way to weaponize it. So, and this has been going on through the course of human history as well. Talk to me about the history of germ warfare. I mean, starting even with like the Mongols.
Yeah, so there have been, attempts to use disease as a weapon of war for centuries. You mentioned the Mongols. This was actually a battle at a city called Kaffa in near the Black Sea, where the Mongol army was attacking it uh, right at the start of the Black Death. So the plague sweeps in, and some of the Mongol soldiers start dying, and so they decide, like, what we're going to do is we are going to put our dead soldiers in a catapult, and we're gonna fling them over the walls of this city and to try to infect the people there. So they believed that what happened was that they would poison the air, and that miasma would then make people sick there. People did get sick, but, the fact is probably had nothing to do with the corpses. Probably rats were coming into the city carrying the fleas that then carry the bacteria that cause the plague. But they were that might be an early example of biological warfare, at least attempting to do it. Biological warfare really, really takes off in World War II. where you have countries like Japan, the United States, and the Soviet Union all really gearing up to major biological warfare programs. In the United States, where I focus on in my book on I it's fascinating to me because what they did is they took advantage of pioneering work in the 1930s. There were scientists who were American scientists who were really effectively demonstrating how it is that the air can harbor life and how it is that diseases can spread through the air. Uh, Really important insights. And basically, the U.S. Army said, like, okay, we're going to take all that. We're basically going to, classify as much as we can of it, and we are going to build a facility, Camp Dietrich, where we are going to use all that knowledge to design biological weapons, anthrax bombs, things like that, and that then continued on an even bigger scale after World War II. The United States, built enough spores to kill all the wheat on Earth, and then it wasn't until the 1970s that the United States decided we're not going to do this anymore. A treaty was signed with the Soviet Union. We know now that the Soviet Union pretty much ignored the treaty they just signed and created even scarier things. And so, yeah, so there is this long, long history of using the aerobiome uh, potentially as a weapon of war to weaponize airborne disease, which
To
is
me,
ironic.
that's more terrifying than nuclear war. I mean, just because of the nature of something that attacks your body and it's slow. I mean, being just, liquefied within, a quarter of a second or, an instant is a lot less scary to me than watching your whole family just slowly die. I mean, ugh.
Yeah, no, I mean, it is terrifying to think about these scenarios in which these weapons could, lay flat an entire city with anthrax, for example. And that fear just kept growing and growing and growing through the 1980s, the 1990s. And, so you would have like US officials like coming on TV and saying like, we need to we need to fight terrorists or we need to fight Iraq because, and they would hold up like a bag of sugar and say, if this was full of anthrax, you could kill everybody in Washington, D.C. But the fact is, I mean, it's just a fact that like the number of people who died in the past century of biological warfare might be in the tens of thousands. I don't mean to diminish those deaths, but it all mainly happened in Japan when Japan invaded China and used biological warfare there. But since then, like, it has not lived up anywhere close to this science fiction. I mean, movies have been made, about this. Novels have been written. We all have this image in our head of airborne destruction, but it hasn't happened. What has happened is that, the United States government used that fear to help justify a war in Iraq, where hundreds of thousands of people died, where, we spent $1 trillion. And when soldiers went to look for these, anthrax labs and so on that the government had assured us were they had good intelligence were there, they weren't there. So we have to be careful. Airborne diseases. It is unquestionably terrifying because it's everywhere. It's invisible and so on. But if we let the fear of it itself can actually be just as destructive.
What are we doing to prepare for the next pandemic? Because it sounds like one is coming eventually, almost inevitably. I mean, what are we doing? I mean, it seems like we clearly must have redoubled our efforts here, having just, experienced one. What are we doing specifically?
Well, who do you mean by we?
Well, yeah, the scientific community, I guess, more than anything. I'm not counting on the politicians. I just mean, are we doubling down on our efforts to study these things or profiling potential disasters on the horizon and focusing our energies on prevention or
Well, certainly, uh, in in the past 5 years since the COVID pandemic started, there has been a renewed focus on trying to figure out, how new pandemics start and how to deal with them when they do start. And part of that involves how do you develop vaccines quickly? Part of that probably will involve figuring out how they spread. And if they're airborne, there are a bunch of things that we know can be potentially useful. Actually having a real supply of masks and N95s um, for our hospital workers and for the public would be nice. You know, in the COVID pandemic, people thought there was a stockpile that would be there for them, and it turned out that stockpile would drain down terribly low. Um, so, um, so we need good stockpiles. We need this kind of research. We need monitoring to be able to understand how these things are spreading. Now, the scientists, there are scientists who do this kind of research, but they're not going to be able to do it unless they have the wherewithal to do it. If the United States is backing out of the World Health Organization, if the United States is shutting down USAID, which does pandemic research, if the United States is, drastically cutting back on funding across the board for medical research, this work won't get done.
Wow. Well, we've did one of the gloomiest notes of all. This is, oh, good God.
But
This
that's
is
not
endlessly.
but that's not vi that, that's not viruses, that's people.
Yeah. And well, that's arguable. Some of them are subhuman, I think. This is endlessly fascinating, but there is a lot of gloomy information in airborne. Um, the germs are winning. Tell me, yeah, tell me
No, I
something
know, I
hopeful.
would say
Tell me something hopeful. I need to hear something hopeful that you've learned throughout your formidable research here.
I would not say, "Oh, the germs are winning." I mean, I think the germs are proving to be, a serious foe, but, you do need to step back and recognize, like, hey, like, a child in the 1800s, didn't have very good odds of surviving childhood because of infectious diseases. Because of measles and tuberculosis and all sorts of things that were incredibly common then and, thankfully are not now. So, there is concern in the United States that right now there's a measles outbreak in Texas where people are under vaccinated. But, we're concerned about an outbreak that, as we're talking, has so far probably affected maybe 15 people. Whereas, even in the early 20th century, thousands and thousands of people were getting measles every year. Polio, like the polio virus is not winning. The polio virus, was incredibly widespread in the United States, and now, like when one report comes up, we get worried. We should be worried, but I'm saying, um, you know, we actually have the capacity to improve our lives. And people have faced these kinds of big challenges and even bigger challenges in the past. So, I'd just say like let's get back in the fight.
He is Carl Zimmer, one of America's preeminent science journalists. He is the author of 15 books, most notably to this conversation, Airborne, The Hidden History of the Life We Breathe. Thank you, Carl, for joining us today. You were great. Thanks for fielding my dumb questions and so patiently and elucidating on them.
Look, Jonathan, those are excellent questions. I'm gonna just keep driving that home. Thank you for having me on. I really enjoyed the conversation.
A Fresh Face in Hell with Jonathan Evison is brought to you by Fresh Face Pods and produced by Jason Botkin and yours truly. Check us out on Instagram, YouTube, or at our website at freshfacepods.tv. Don't forget to subscribe to our newsletter for updates and special content. And if you love the podcast, by all means, run out and buy all of Jonathan Evison's award-winning novels wherever books are sold.